Hello to everyone. I am Professor Raja, working as Assistant Professor, EC Department at SNS College of Technology, an autonomous institution, Coimbatore. In this YouTube video, we are going to discuss the 1990 T204 microcontroller and embedded system subject under the topic 8086 interrupts. So based on my previous video, you know about what are the various internal blocks in 8086 and addressing modes of 8086 and instruction sets of 8086. Now in this YouTube video, we are going to discuss the various interrupts available in 8086. In first 8086, whenever they received interrupt, they stop the current running program and give the most important task to the interrupts. An interrupt is used to cause a temporary halt in the execution of program. The meaning of interrupts is to break the sequence of operation. While the microprocessor is executing a program, an interrupt breaks the normal sequence of execution of instructions, diverts its execution to some other program called interrupt service routine. So whenever 8086 receives interrupt, they stop the current execution and give the entire preference to the interrupt service routine. After executing interrupt service routine, IRET returns the control back to the main program, and interrupt processing is an alternative to some other problem happened. So why the interrupts is happen means interrupts are particularly useful when interfacing input-output devices that provide or record data at relative low data rate transfer rate. Also, the various sources of interrupts are an external signal applied to non-maskable interrupt or INTR input pin to hardware devices, execution of interrupt instruction by software interrupt raised due to some error condition produced in 8086 instruction execution, that is divided by 0, overflow between errors and etc. So in general, interrupts is divided in two types. One is the hardware interrupts, another one is the software interrupts. So hardware interrupts are further divided into maskable interrupts and non-maskable interrupts. And these maskable interrupts are the programmer can choose to mask specific interrupts and re-enable them later. Non-maskable interrupt means the programmer cannot control when a non-maskable interrupt is served. The processor has to stop the main program to execute the non-maskable interrupts. In general, non-maskable interrupt is not controllable interrupts and maskable interrupts means controllable interrupts. Whereas software interrupts are desired by user, it is having a type of 256 type. 256 means from 00 to INTFF we have the software interrupts. So this is the 8086 CPU pin diagram where how this maskable interrupt and maskable interrupts are marked. So under 18th pin the maskable interrupt is there, and under the pin number 17 non-maskable interrupt is there. Then how this processing interrupt by 8086 processor. So they executes the INT instruction, interrupts the INT instruction using the assembly time, moves INT instruction to the vector table. Magically vector table occupies the location 0000H to 003FFH to the program memory. It contains the code segment and the instruction pointer for each kind of interrupt. So non-maskable interrupts are happen due to this ways: used during power failure, used during critical response times, used during non-recoverable hardware errors, used as watchdog interrupts, and used during memory parity errors. So these are the ways how non-maskable interrupts are happened. Then software interrupts. Software interrupts are used by operating systems to provide hooks into various functions. It is also used as a communication mechanism between different parts of a program. Hardware interrupts are created by keyboard, mouse, hard disk, floppy disk and a DVD drive. It is used to handle external hardware peripherals such as keyboards, mouse, hard disk, floppy disk, DVD drivers and printers. And these software interrupts are expensive in terms of time and processing power. It is also used to handle external hardware peripherals such as keyboards, mouse, hard disk, floppy disk, DVD drives and printers. Without interrupts, the system are very simple. That is, whenever the interrupts came, the CPU has stopped the current execution of program and give the routine to the already running program. All microprocessor architecture have inbuilt interrupt service capability. So for the software interrupts, they are divided into 4 types, that is type 002, type 04 interrupt, type 52, type 31 interrupts, type 32 to type 255 interrupts. So based on these types, each are doing a separate function. And type 0 is called divide by 0 error, type 1 is called single step or trap interrupt, type 2 is called non-maskable interrupt, type 3 is called 1 byte instruction, then type 4 is called overflow interrupt. So thank you for watching my video. In the next video I am going to discuss some of the 8255 peripheral interface